In this lecture, we are going to create circles. First, we are going to find the circle tool inside the sketch application. And then, using that tool, we are going to draw a circle and finally we are going to constrain it completely. Let us do that in CATIA. You can see this is the gateway of CATIA. So, I'll open a new file. And I have to enter inside the sketch application. So I'll select this icon, which is the sketch, and select a plane. I'll select this plane. Now I'm inside the sketch application of CATIA. For finding the circle tool, it is pretty easy because wherever the profile tool or the line tool will be there, the circle will be positioned near to it. You can see here, this is the profile tool and we have the circle here. In CATIA, you can also move over to this profile and you can get circle here. There are so many circles, but the important thing is this circle. The complete circle. If we know how to create a complete circle, then we can always use the trim option to trim and create a semicircle or any part of the circle or a combination of circles. I'll click on this circle tool and maybe I'll click somewhere here to create the center point and drag. You can see a circle is formed. Now let's move to Solidworks and find the circle tool. This is the gateway of Solidworks. So I'll click on new. I want to create a new part. Select part. Click on OK. Now we'll go to sketch and click on the sketch icon. Maybe I'll select this plane. Now, as I have told you, if you want to find the circle tool, you just move over near to the line tool. You will always find the circle tool near to the line tool. So, here you can see this is the circle tool. It is showing how to generate a circle. Just click on this circle icon and maybe I'll click here and drag. You can see a circle has been generated. Press on the escape key to exit from the command. You can see here, this is the circle. Now, for constraining a circle, we require three relations. First is the radius or the diameter, which is a dimensional constraint. And second is the position of the point, that is the center point. So, we have to position this center point and we have to give the dimension to this circle. For positioning the center point, we require the reference with the x-axis and the y-axis. Let us give that. Let us first coincide this center point with the origin to constrain it, so that circle's center point will be 0, 0. Select this circle center point, press on the control key and we have an origin here. You can see, select. Both of these points we want to coincide. You can see. Now we just need to give the dimension. So we'll take smart dimensioning and select this circle. We can give the diameter here, click, and maybe I'll give a diameter of some 100. Press on the escape key to exit from the command and you can see here the sketch is fully defined. Also the color is black. So the circle is completely constrained. Let us now undo this constraining. Now let us give the dimensions of the center point with relation to the axis. So for doing that, we can use horizontal dimensioning between this point and this point. You can see this is the horizontal dimensioning. Click and maybe I'll give some dimension as 60 mm. Now we will take this dimensioning, vertical dimension between this point and this center point. This value is also maybe some 60. So you can see I'm able to give the dimension. You can also use this smart dimensioning. There is no problem, but I wanted to show you what is a horizontal dimension and what is a vertical dimension. As the name suggests, horizontal dimension is used for giving a dimension between two objects in a horizontal axis, and in vertical dimension, we will give the dimension in a vertical axis. Now let us take smart dimension and give the diameter to this. So this diameter is some 100. So we are giving three things to constrain the circle. First is the diameter or the radius of the circle, then the position of the center from the x-axis and from the y-axis. Now let us move over to CATIA and do the same. Here already the circle we have created. Now let us select this point, that is the center point of the circle, and select this origin point. Use the control button for multiple selections. So these 2 points we have selected. Now let us take these constraints coincide. You can see. Now just give the diameter or radius. Double click and I'll give a diameter of some 100. So you can see this is green, so it is completely constrained. Now let us undo. For undoing a operation, you can always use the Ctrl+Z key on the keyboard, or you can also use these icons. In every software this icon will be present. Now let us take dimensioning. Double click on this dimensional constraints and let us give this diameter as 100. Now let us give the position from this horizontal axis to this point. This is 60. From vertical axis to the center point, this is also 60. So this is how a circle is made and it is constrained completely. In the next lecture, we are going to practice an example. In this lecture, we are going to see the applications of circles using example 5. We are going to generate this drawing. Let us create the drawing in CATIA. Here, first we are going to create this boundary, which is a rectangle. The rectangle is of 80 into 30 mm. Let us create a fully constrained geometry of the rectangle. I'll directly use the rectangle tool, or you can also go for 4 lines and create the rectangle. Let us take rectangle tool directly and create a rectangle something like this. In this type of drawings, it is always beneficial to create the circle center at the origin. So, the rectangle, or so to say the boundary, must be symmetric with respect to the axis. So what we will do is, I'll double click on dimensioning and let us give the dimensions first. This dimension is 30. Again, this dimension is 80. Now let us hold the drawing and move it to create it symmetric with respect to this axis. Now to create it symmetric, there are some constraints which you can use. There is a symmetric constraints. Most of the softwares are having it. So you can search for it. For getting the symmetric constraint, you have to select 3 elements. First is, I'll use the control key for multiple selection. The elements which are going to be symmetric. Then the third object is the axis about which it is going to be symmetric. So what does symmetricity mean? Suppose this is 80. So from this axis to this line it will be 40. Again from axis to this line will be 40. You can also give the dimensions. But I want to show you the symmetric constraint, which is very useful. Now after selecting these 3 elements, do remember, first is this element, second is this element, and then about which axis we are going to create these 2 elements as symmetric. So this is the symmetric axis. I'll select this, which is the geometrical constraints, and here we have symmetry. Click on symmetry. Click on OK. Now you can see it is completely symmetric. If I delete this 80 and the symmetric relation is there, if I move this, you can see this line is completely symmetric to this line about this center axis. Now let us undo to bring back our dimension. You can see the dimension 80 has come. Now the same symmetricity I will apply for this line and this line about this axis. Symmetry. You can see the rectangle is completely constrained and it is also symmetric about the axis. Now let us see the drawing. Here we have three circles. The axis of positioning of these centers is 15 mm from this line. So all these three circle centers are in a single line. So let us create three circles first. I'll take circle and position the circle here. Here you can see during creating some elements, what will happen is you will get this auto constraints. If you move, you can see here a tangency constraint has been developed. I want to remove this. Select this and delete. When you move, you can see. Now I'll take this circle center and use the control key for multiple selection. Select this horizontal axis and I'll go for coincidence. Similarly, I'll take this circle center, press the control key, select vertical axis and I'll go for coincidence. So you can see the circle center is positioned at the origin. Let us go for undo. During creation of the circle, you can directly select the origin. You can see here at 0, 0, the origin, we are going to select the center of the circle. Select and create a circle. Automatically the circle center has been positioned at the origin of the drawing. Now we just have to give the diameter. In the drawing you can see the diameter is 20. So double click and here we will give a dimension of 20. Now let us go for the other circle. I'll select this circle and click here. We'll take this point, use the control key and we'll select this axis. Here we'll go for coincide. You can see, if you see the dimensions, the diameter is 10 mm and the position is 15 mm from this side. Let us give the position first. From this side to this center point, this is 15 mm and the diameter is 10 mm. The circle is completely constrained. Similarly, I'll take another circle, position it somewhere here. Now I'll take this point and this axis. Coincidence. Again, we'll take dimension. The diameter we will give as 10 and the position of this circle. If you see here, the position of this circle is 65 mm from this end. So we'll take this point and this line. This is of value 65. And you can see we have completed our complete drawing, which is a fully constrained sketch. Let us go to Solidworks. We are inside the sketch application of a new file in Solidworks. Here also we'll take a rectangle. Click on this rectangle. We'll make a rectangle something like this. And as I have told you, to create the rectangle symmetric about the axis, let us create the symmetricity. Let us search for the symmetric constraint. Select this line. Select this line about this center point. Here in add relations, we are not getting any symmetric relation. So in SolidWorks, the symmetric relation is not present. So we will go for our usual method. We'll give the dimensions. Now this dimension is 80 and this dimension is given as 30. Let's zoom a bit. And now let us give the dimension. We'll take dimensioning. from this line to this point, 15 mm. Again, from this line to this point, 40. The rectangle is completely constrained. Now we will go for the circle. Select circle. We'll create a circle somewhere here. And by using constraints, we will coincide this point with this origin point. You can see coincidence. Now we can give the dimension. The diameter of this circle is 20. You just relate the process that I have used in CATIA with the process that I am adopting in Solidworks. The process is 100% same. Only few tools may be missing in some software and it will be existing in some other software. But the basic process is same. So these are the techniques that you should follow while operating any new software. Here, if you see this circle, it is black, so it is completely constrained. Now let us take another circle. I'll create the circle somewhere here. Now this circle center and this circle center has to be in a single line. So we can display the center plane, which is this front plane. You can see. Right click and here show. This is the center plane. So we can use this center plane and coincide this point with this plane. Coincident. You can see. Now we'll take the dimension. The diameter is given as 10 mm and the position, that is from the center to this line, this is given as 15. Now let's take another circle and draw somewhere here, and we'll use the same process that we have used in CATIA. We'll take this point, use the control key, select this plane and we'll use coincidence. Now let us take smart dimensioning. This point from this edge, this is of dimension 65. Now let us give that diameter, which is 10 mm. But here you can see the radius or diameter of this circle is equal to this circle. So why should we give 2 times? We will select this dimension and delete it. Now let us take this circle, use the control key and this circle. Both of this circle will use equal. So what has happened is both of the circles have been given the same radius value. So this is also possible. You can give equal radius. Also you can give equal length to 2 lines. But this equal is not there in CATIA. It doesn't work efficiently in CATIA. So some tools may be there in some software and it may not be there in some software. But overall the technique is same. You can see here, this is a completely constrained geometry that we have created in Solidworks. And the process that we have used is exactly same as CATIA. But some tools here and there will be some difference. In the next lecture, we are going to see example 6. In this lecture, we are going to see how to create this example 6. This is the drawing that we are going to create. Here, the dimensions are very few, but the technique that we are going to use is important. First, we will create this R20 circle on both of the sides and at a distance of 40. Let us create a circle at this origin directly. And we will give the dimension. This is of 40 diameter. Here we can also feed the radius. Click on OK. Now we'll take a circle again. We can trace the axis here. but this is for advanced users. For you, you can create it somewhere here and click this center and this horizontal, and we will go for coincidence. Now we'll take dimension. This radius value is 20. Now the distance between these two points is given as 40. Now let's take two lines. We'll use this line tool. We'll create a line here and create another line here. We'll make this line tangent to this circles. So we'll take line, use the control key for multiple selection and select this circle. This is tangency. Again we'll take line and this circle, both of these tangency. Again this line and this circle, tangency, line and circle, tangency. You can see everything is green, so it is constrained. Now we'll take this quick trim. You can also double click to lock this so that we can use it repeatedly. I will double click on this icon to lock it. Select this line and this line. So we are removing the unnecessary portions. You can see. During trimming also you have to follow a process. You have to trim from one side only. Don't trim here and there. Otherwise it will create some elements which you cannot trim. And if you trim them, then the entire constraints will be removed. So you can see the outer boundary we have created. Now this inner one also you can create in this same fashion. But in some softwares like in CATIA and also in Solidworks, we have a tool which you can use for directly creating this type of feature. Here you can see elongated hole. This is the same feature that we have created here. So we will click on this elongated hole, select this origin point and select this point. You can see even the dimension also has been generated. You just double click and give the diameter or radius, that is 10 mm. The sketch is completely constrained. The same thing we are going to do in Solidworks. Here we are inside the sketch application of a new file in Solidworks. Here we'll take this circle and we will create the center point at the origin. You can see. Now we'll give the dimension to this. We'll use the smart dimensions. Select this circle. This diameter is 40. 40, enter. The circle is completely constrained. Now you can see I'll take another circle. Maybe you can see it is tracking the origin point. You can click here or maybe I'll click somewhere here and generate another circle. Now as we have done in CATIA, we have used the axis and we have coincided the center point on the axis. You can do that by using the plane that is there here. This front plane, you can just show this front plane and coincide this center point onto the plane. But I'm going to show you another option. You can select this point, which is the center point of a circle, of the first circle, and this point, center point of the second circle, and both these points I'm going to give a relation as horizontal. So both of them are positioned in a horizontal axis. Now I'll take this circle and use the control key on the keyboard and select this circle, equal radius. Now just we have to give the distance between this point and this center point, which is 40. 40, enter. You can see. Now let's create the two lines. You can use the snapping feature of a software. If I move over to this point, you can see it is choosing the quadrant point. Click, and again you can also click here. Press on the escape key. You can see it is completely constrained. So what it has done is it has taken the quadrant point of this circle and it has created a horizontal line. so that automatically it is tangential with this circle. Or as usual, like we have done in CATIA, you can take a line something like this, press on the escape key, and you can give tangency. I'll take this circle, use the control key for multiple selection, take this line and give tangency. Again, circle, line, tangency. You can see. Now we will take trim and select this line and this line. Now let us select all this line to trim. So we have created our boundary. Now as we have done in CATIA, here also we have the similar option. It is called straight slot. When you select the straight slot, there are many options, but we need not see those. We will only see this option. I'll just select this center point and we select this center point. You can see. Now we just have to give the dimension. We'll take smart dimensioning and select this arc. This is of radius 10. So with this, we have completely constrained the sketch. This completes our example 6. Here I could have used many complicated drawings, but I want you to understand the concept. For drawing any geometry in a software, there is a simple technique. You have to understand the technique, and this same technique whenever you apply in any other software, you will be very easily able to learn it. Here you can see, in Solidworks we have used some tools, and in CATIA also we have used some tools. But the procedure of creating the sketch is very same, or so to say exactly same. So this is what I want you to learn. In the next lecture we are going to explore reference elements and corner editing tools. In this lecture we are going to explore the reference elements and the corner editing tools. Reference elements are used for converting normal elements into reference. We will see the application part of these reference elements in the next example, which will be done in the next lecture. But for now, we have to know how to create these reference elements. Then we will find the chamfer and the fillet tools, which are the corner editing tools. And we will see the application of this chamfer and fillet by using the rectangle that we have saved earlier. Let us first create the reference elements. Let us create some elements. Now, if you want to convert this into reference that is not part of the active sketch, then you have to select this and select a convert to reference element icon. You will find the reference elements in this sketch toolbar, which is this icon. You can see. This is the sketch tools. And in the sketch tools, you will have these reference elements here. Select this line and click on this. You can see it has converted into this dashed line. This is the reference elements. And once you exit this sketcher workbench, you can see that line has been hidden because it is a reference element. That line has been used as a reference to create the other elements of this sketch. Now again double click on this sketch. You can see the line is here. If you want to make it solid, then again you have to select this and select this icon. Now to find this icon in CATIA, you can just right click and you have this sketch tools. In sketch tools, you have this icon here. So this is the meaning of reference elements, and in CATIA, the reference element option is here. Now let us find it in Solidworks. Here also we will create some elements. These are few lines. Press on the escape key to exit from the command. Now just select any line, maybe this line, and as soon as you select it, you will get this small toolbar. You have the construction element here. Click And you can see it has been converted into construction element or reference elements. The application of this reference element we will see in the next example that we are going to create. But now this is the way we can create reference element in SolidWorks and in CATIA. So you can find this reference element in any software. You can see the icon. You can also study the icon and know what the tool is for. Here there is a solid line and there is a dashed line and there are arrows. So you can convert a solid line to construction line and construction line to solid line. When you select this, you can see here it has been converted into a construction line. Now if you take a circle also, this is a circle, just select the circle, and if you select this, it will become a construction element. Now if you exit the sketch, you can see these are dotted, so it is not a part of the active sketch. Double click on this and we will go for plane normal. Here we can select this normal too. So this is reference elements. Now let's find the chamfer tool, that is the corner editing tools. Here you have this fillet and chamfer. You just move over to this left side, you see the tools. These are circle tools, spline, and when you move over here, this is the symbol for a fillet and this is the symbol for a chamfer. So these two are the icons. In any software, the chamfer and the fillet will be having this icon design. So you can just have a look and you will be able to find this. If you select this sketch fillet and you can apply this fillet, you can see this is a fillet. So we have our fillet and chamfer here. Similarly, if you go to CATIA, you can see here these are the fillet and chamfer. Now let us take our 100x50 rectangle that we have saved in our desktop. We'll go to File, Open, and in our desktop, Rectangle. Click on Open. Now double click on this rectangle. You can see here the rectangle is opened. Similarly, we'll go to SolidWorks and we'll go to File, Open. And in desktop, we have this rectangle here. Click on Open and you can see the rectangle has opened. Now just double click on this rectangle so that we can enter into the sketch interface. Now let us create the corners. Here this is fillet. Click on fillet. You just have to select the corner. You can select the point, that is the vertex, or you can also select both the lines that make up the corner. You can see a fillet has been applied. You can give the dimension here. Maybe I will give some 15 mm fillet. Click on OK. You can see a 15 mm corner has been formed. Now let us go to chamfer. Before that, we will go to CATIA and apply the same fillet. Here I will use this. In CATIA it is called corner. In SolidWorks it is called fillet. But both the tools have the same function. We'll select this corner, select this and this. Now double click here and we'll give a radius of 15. Now let's create a chamfer. Click on chamfer. We'll select this line and this line. You can see here this angle constraint has automatically developed. You can give the angle, you can make this 45 degree, 60 degree, whatever, and this length. I will not use this length, so I'll delete it and I'll define my own length from here to here. This length, suppose I want as 10 mm. Even you can also give length to both the sides. We'll take a chamfer here and we'll delete this too. This and also this angle which has been formed automatically. You can see we'll delete this and we can define our own constraints. From this point to this line, we will define as some 10 mm. Again, from this point to this line, this I will define some 20 mm. You can see. So you have total freedom on how you want to create the chamfer and the fillet. Now let us move to Solidworks. Now here we will see the chamfer tool. You can see sketch chamfer. Select. We'll take this corner, or we can also use these two lines. Here we have option distance angle and distance. If you take distance angle, you can create a chamfer with 10 mm distance and angle as 45 degrees. But here I have used distance to create this. So the distance has automatically been given. I'll double click this and we can give the dimension. You can see 20 into 20. You can also select this and delete, and you can give your own dimension from here to here. You can give this dimension as some 10. You can see. Now the same thing we can do here. We will take chamfer, and from here to here we will create chamfer, but in this case we'll go for angle distance. You can see this is 45 degrees and this is 10 mm. So this is how we can create chamfer and fillets. The procedure for creating chamfer and fillet is same for CATIA and Solidworks. Only the application of tools is a bit different. So similar is the case for all the other softwares. The procedure for creating these corner editing tools is same in all the softwares. Only there will be a slight change in the application of the tools that you can easily identify after this course. In the next lecture, we are going to practice example set 3, which will be application of all that we have learned till now. In this lecture, we are going to practice example 11. We are going to apply whatever we have learned till now in this course. This is the example 11. For making this drawing, we have to follow a structured method. First, we will create this base, and then we will create this upper portion, and then both of them we will connect. So this is the procedure that we have to follow. And remember, all the chamfers which are this, all the chamfers and the radius, or so to say the corners or fillets, will be formed at the last. That is, you should always form the corner at the last. It may be a chamfer or a fillet. Now let us start this example by using CATIA. In CATIA, I have opened a new file and now I am inside the sketcher interface of the new file. This is the drawing that we are going to create. Now first we have to create this bottom area without the chamfers. So let us create a rough sketch first. You can see the dimensions. This is 20, 10, this total is 100, this is 20 and the height is also 20. Let us create a rough sketch first. If you have a drawing which is symmetric about the center axis, then you should always create the sketch symmetric about this datum axis. So let us create the drawing symmetric about this vertical axis. We will create a rough sketch. I'll select here to create the first point, second, and you can see I'm creating a rough sketch. It is just a rough sketch, so you can create as you like. First, let me position this. I'll select this line and this axis. Coincident. You can see this line and this axis. Coincident. Now, in CATIA, we can create symmetricity between two objects. So we can take this line and this line symmetric about this axis. Symmetry, or also you can give the dimension. Suppose this total is from here to here. this total dimension is 100. Hence, from this line to this center axis, this will be 50. So either of the ways you can use, there is no problem. Now this height is 20 and we are left out with only this height, which is 10. You can see. Now this dimension is also left out, that we have not given. So from this line to this line, this dimension is given as 20. You can see the base is fully constrained. So you have to move phase by phase. We have created the base and it is completely constrained. Now we will move on to the top section. But before that, we will create the same base in Solidworks so that you can compare the procedure of creation between both the softwares. For this example, this is a new file and it is the sketcher interface of the new file in Solidworks. Now we will take line and create a sketch, which would be a rough sketch. You can see we are just creating horizontal and vertical lines. Somehow this line is inclined, so I'll just select it and make it vertical. Now I have to coincide this with this center axis. So I will select this front plane and show it so that I will get this center axis. Select this line and select this center axis and go for collinearity. Again, select this line and this center axis and you can go for collinearity. Let us hide this front plane. We don't require it now so that our sketch will be clear. Now let's give the dimensions. As we don't have the symmetric constraints, so there is only one option. We can give the dimension and make the object symmetric about this center datum plane or the datum axis, which is y-axis. Now let's take the dimensions from here to here. This dimension is 100. Sometimes you will have problem like this. So you just have to move this and correct the sketch. You can see this is the form that we want. Now I'll take dimensions from this side to this origin. This is 50 so that it will be symmetric. From here to here, this dimension is given as 20. This height is given as 20. From here to here, this is also 20. And this height is 10. And you can see we have created a fully constrained geometry of the base. Now let's move to the top portion, which is this area. Here if you see, it is a collection of circles. This is an outer circle which has been made by taking this as the center. So this is a R30, radius 30 circle. It has been created taking this as center and its center is positioned in this line, or so to say axis, which is at 15 plus 35 mm from this line. So let us create a reference line. So this is where reference elements will be used. I'll take line and create a reference line. Of course, this is not a reference line, so I'll select it and click this, convert to reference or construction or standard element. Now we will give the distance from here to here. This is of value 15 plus 35. No need to calculate. All high-end softwares will have mathematical calculations built into it. So this will be 15 plus 35. You can see it is 50. 15 plus 35, 50. The circle is positioned in this center axis. So what I will do is, I will select this axis as the position of the center. Let us see what I am talking about. As this is on, so whenever we create any new elements, automatically convert into reference elements. So I'll deselect it, you can see. Now I'll take this point and this axis. We'll go for coincidence. You can see. Now we'll take this point and this construction element coincide. Now just we have to give the dimension. The radius has been given as 30. You can see here, this is 30. So we'll take dimension, we'll select this and radius is 30. The circle is completely constrained. So you have to input one element, constrain it, another element, constrain it, another element, constrain it. This is the process you should adopt so that there will be no confusion, however complex the figure may be. Now the same circle will make it in Solidworks. Here also we will take the reference element. We'll take a line. You can see I have generated a line. Press on the escape key to exit from the command. Select this line and directly I'll convert this to construction geometry. We'll take dimension from this line to this base. This is 15 plus 35. Enter. 50 dimension has been given to it. Now we will take a circle. Maybe we'll create the circle somewhere here. We'll take the center point of the circle and we have to take this vertical axis. It's not there, so we have to show it. Here you have to select this right plane and show. You can see the axis has come. So we'll just select this. Use the control button for multiple selection and select this point. Coincident. You can see. Now we'll select this right plane and hide it so that there won't be confusion. We'll take this center point. Again, use the control key for multiple selection and select this construction element. Coincide. You can see. The center point has been positioned. We'll take the dimension of this circle. This radius is 30, so we can give 60 as the diameter. So the circle has been fully constrained. Now let us move to the next element. Here, the next element is this circle. This circle is of, or so to say, this arc is of radius 30 and it has been positioned 40 mm from this circle's axis. So we will create a construction element. We'll take a line. We'll create a construction element here and we'll select this line, convert to reference or construction geometry. Smart dimensions, we'll select this line and this line. The distance is 40 that has been given in the drawing. Now we'll take a circle and position it somewhere here. Press the escape key to exit from the command. We'll take this point, that is the center point of the circle, and we'll select this construction element, which is 40 mm from the earlier construction element. And we'll go for coincidence. Now we want this center axis so that we can position this circle center. Again, we'll click on this right plane, right click and show. This is the axis. Use the control key and this is the center point. Both of this we will coincide. Now we have to take the dimension of this circle. The dimension of the circle that has been given is, you can see here, this is 30. So we'll give a diameter of 60 because 30 into 2 is 60. Press on the escape key to exit from the command. Now we will take trim entities, trim this, this and trim this. Let us hide this right plane so that we can see the figure better. Now let us move to CATIA and create this same circle. So what we have done? We have taken a reference line. It will be a horizontal line. We'll convert this into reference. We'll take dimension from here to here. This we had given as 40 mm. And we'll take a circle, position it somewhere here. This is reference element, so we'll convert it into solid element. And we'll take this point, use the control key for multiple selection, select this reference element and coincide. Again we'll take this center point and we'll take this axis, which is the vertical axis, or so to say the y-axis, and coincide it. Let us give the dimension. This dimension is given as 30 radius. Now we'll use the trim. Select this. For trimming, you can just double click so that you can use again and again. You can see. So in both CATIA and Solidworks, we have formed this outer boundary of the top portion. You can see. When I'm doing, forget about learning the software. You learn the technique. Why I am doing this simultaneously in these two softwares, that you must understand. This is only to give you a clear idea that the procedure for making the drawings is same in CATIA and Solidworks and any other software. You have to learn the procedure, or so to say the technique, to do the sketch, and not exactly the tools. The tools will be same or maybe a bit different, but it doesn't matter if you know the procedure for making a sketch. Okay, now let us proceed further. Let us create these two lines and then we will go for this circle. These two lines are at 20 mm apart and they are symmetric. Let us do that. What I'll do is, I'll take this line tool, create a line here, and again I'll take line tool and create a line here. You have to be very careful while creating the objects. If you see here, there are some, you can see, there are some symbols, some tracking lines which are generated. This will create auto constraints which we don't want. Always try to prevent auto constraints, at least during the learning process. And later on, when you expertise in this software, you can go for any type of auto constraint. It doesn't matter, because you will be having the capability to handle constraints efficiently. Now, I have created these two lines. Let us give the dimension first. From here to here. Between these two lines, the dimension is given as 20. So, from here to here, this is 10 mm. Or I can also give symmetricity in CATIA, because it is present. For giving symmetricity, I'll select this line and this line about this axis. Symmetry. You can see. Now, I'll just double click on quick trim. Trim the unnecessary portions. You can see. Let us go to Solidworks and create the same two lines. I'll take line here. From here, I'll draw a line which is vertical. Press on the escape key to exit from the command. Again, I'll take line. From here, I'll create a line something like this, which is a vertical line. Press escape key to exit from the command. Now let us give the dimensions. Select on smart dimensions. From here to here, between these two lines, the dimension is 20. Again, from this line to this origin point, this is of 10 mm, so that both the lines will be symmetric about the origin point. Now let us take trim entities. Trim this line, this line, this line and this line. Also will trim this line and this line. You can see, in both CATIA and Solidworks, we have created the same geometry. Now let us move one step further and create this circle. This circle is also aligned about this center axis and it is at 15 mm distance from this upper axis, or so to say the axis which contains the center of this circle. Now let us generate the construction line, or we can also go for giving this 35 mm from this base line. So let us take a circle here. I'll create circle outside. You can see I'll just delete this and create the circle again. When I'm creating the circle, these are auto constraints. You can see. So as soon as I click here, it will create a tangency constraint between the reference line and this circle. I don't want that. I'll select when I get no auto constraint. At this point I'll select so that there is no auto constraint and my circle is free. If you just move around, the circle is free. Now I'll take this center, use the control button on the keyboard for multiple selection and use this vertical axis. And what I'll do, I'll go for coincidence. And from here to this point, the dimension has been given as 35. Also, there is a diameter 20 mm. Let us give the diameter. Here we can select diameter as 20. Click on OK. You can see we have created a completely constrained circle. The same circle let us create in Solidworks. I'll take circle, create a circle outside to prevent unnecessary constraints. We'll take this point and coincide with this center axis. The center axis is not present, so I'll select this right plane and show it so that we'll get a reference of the center axis. Select this plane or the axis and this center point. Go for coincidence. Now we will take dimensioning. We'll give this center to base. This dimension will give as 35 as given in the drawing. And we'll select this circle and give a diameter of 20 mm. You can see. Let us hide this right plane. So we have created the same geometry in both CATIA and Solidworks. Now let us move for giving the corner dimensions, that is the chamfer and the radius. First let us give the chamfer to this base geometry. Here you can see this is 5 into 45 degree chamfer at two places, that is this side and this side, and this is 10 into 30 degree in two places, this side and this side. Let us give this. We'll take chamfer. Let us zoom in a bit. Between these two lines we have a 45 degree chamfer. You can see here this is 45 degree. We want 5 into 45 degree. So let us delete this and let us give a dimension here. From here to here, this is 5 mm. Now we'll take the chamfer again and this side will give a chamfer. This is 45 degree. Let us delete this dimension and give a dimension from this point to this line as 5 mm. You can see. Now let's move to the upper corner. Here also we will take chamfer. You can also select this corner point and give a chamfer something like this. Let us see the drawing. Here from this point to this line it is 10 mm and this angle is 30 degrees. So here we will delete this dimension. Also we will delete this dimension. And from here to here, this angle is 30 degrees. And if you take dimension from here to here, this is of 10 mm. You can see this is the chamfer that we want. Now again we'll take chamfer from here to here. You can see this is the 45 degree. We will delete this. Also we'll delete this line. Double click on dimensioning. between this line and this line, the angle is 30 degrees, and the dimension between this point and this line is 10 mm. Now let us create these 4 chamfers in Solidworks. Let us zoom in, and as we have done in CATIA, the same chamfers we will create here. Sketch chamfer. Here you can select what you want to give. We'll give angle and distance. The angle is 45 degrees and the distance is 5 mm. Now just select this corner and you can see 45 degree and 5 mm chamfer has been given. Now similarly to this corner also you can select. Directly it has been given. Now we can take distance angle and give an angle of 30 degrees and a distance of 10 mm. Select this line and then this line. The first line that you select will be given a dimension value of 10 mm, and about that same line this 30 degree will be inclined. So if I want a dimension 10 mm to be given this side of the chamfer, then I have to select this as the first element and then this as the second element. You can see 10 mm is given, and about the same line this 30 degree is also given. Very easily we have given the corners in Solidworks. Let's move up and create these fillets. This is radius 8 fillet 4 places. So 1, 2, 3 and 4. We have radius 8. Let us give that. We'll take this sketch fillet and here it is 8 mm. Directly we'll take this corner and this corner, this corner and this corner. Just click on this and you can see all the corners have been given a fillet of radius 8. Now the same thing we will do it in CATIA. You can see these 4 corners we will give a fillet of radius 8. Double click on fillet. Between these two there is a fillet. Between these two there is a fillet. Also you can select the corner and create fillet. You can see. Now double click on this radius. This is 8 mm. Double click on this radius 8. This is also 8. And this is also 8. Now we are left out with only these 2 fillets which are of R4. Let us give them so that we can complete our geometry. You can see. So this is R4. Double click here, R4, and we have completed the geometry in CATIA. Let us go to Solidworks. By mistake it has been rotated, so we can go to this icon and here we can select normal to. We'll go for sketch fillet and here we can select 4 mm. Just select this corner and this corner and click on this OK. Did you learn the software or did you learn the technique? That you have to be very clear. If you have learned the technique and while learning the technique you have learned the software, I have succeeded in teaching you my technique. Because it is the technique that I want you to understand, not the software. If you understand the technique, you can operate any software. On the final day, that is on day 5, we will decode Fusion 360. And on that day, you will understand that the same technique we will use in Fusion 360 and operate it efficiently within 1 hour or maybe 1.5 hours. Very easily. In the next lecture, we will know about duplication tools. which helps us to create highly efficient drawings in the Sketcher application of any software. For creating our drawing easily, there are some duplication tools available inside every high-end CAD software. There are three very important duplication tools which we can use. The first one is circular array, second rectangular array, and the third is mirror. So our objective in this lecture is we will find out each of these tools and we will practice using some simple objects. There are some different names also used for these tools. The circular array may be called as polar array or maybe circular pattern, and rectangular array may be called as rectangular pattern. Mirror may be called as a symmetry. So it depends upon the software. For different software, different type of name may be used, but the function is same. So we are not going to remember the name of the tool, but we are going to remember how the tool actually works. So that is the technique that we are going to see in this lecture. Let us find out these tools in software. First, let us see the circular array or circular pattern. We will see it in Solidworks and then we will go for CATIA. Now we are inside the sketch interface of a new file. I'll take this circle and create a circle, maybe something like this. And I'll create a small circle somewhere here. You can see. Now our objective is to create this same type of circle about this periphery of this bigger circle. I'll just show you what we want. Let us first find where is this circular pattern or circular array. Here there is no circular pattern. I'll show you the symbol. When you move over here, you can see here. This is linear sketch pattern, which is linear pattern or rectangular pattern. Click here and here we have this circular sketch pattern. So this is the tool that we are actually searching. Click on this and we will select this circle which we want to create a polar pattern or circular pattern. Now we have to give the center of rotation. You can see this center point we have to locate. So we will just move it and we will fix it to this circle center. And you can see here what is the angle between which you are going to spread all the circles. Here this is the number of the circles that you want to create. You can see there are 6 number of circles. Let us click on OK. This is what I am talking about. This is called as a circular pattern or circular array. The name is different for different softwares, but the function is same. You have to select the object, you have to select the center point along which the entire objects will be positioned and the number of objects. Let us undo it and let us create it again. Circular sketch pattern, select the object, and now we have to select the point about which this entire array will be positioned. You can see. You can also define angular spacing. Suppose the angular spacing is some 45 degrees. You can see here. At 45 degrees, the other instances, or so to say the duplicates, have been formed. And here we can go for maybe some 8 elements. You can see. Click on OK. And we have formed the circular pattern. Let us go to CATIA. In CATIA, the circular pattern is a bit different. Let us create a circle. Maybe this is the circle. And we'll create a small circle. Maybe here. Now we'll go to insert. And we will find out the array. here in this profile, there won't be the array because it's a operation. So we'll go to the operation menu, and here we'll go to relimitation. Here there is no array. Here also there is no array. And in 3D geometry, there is something different options. So we'll go for transformation and click on this rotate. Click on rotate. Now select the object and we will select the center point along which we are going to create the polar array. Now we will select the reference point on the object that we are going to use for creating this array. And you can see there are 5 instances that are getting formed. Along with the original object, it is 6. So suppose I want only 5 instances to be formed. So I'll go for 4 here. So you can see here total 5 are getting formed. And here you can use a value 360 divided by 5. So it will be the angle between 2 objects. Press on enter key and you can see the array has been formed. So this is how polar array is getting created. Now let us delete this and we will go for the rectangular array or rectangular pattern. For that, let us create a rectangle, maybe something like this, and we will create a circle here. Now we want to create some multiple circles on this rectangular object. Here we have this linear sketch pattern. Click on this and select the object, which is this. We can give a dimension, maybe some 40 mm. You can see, or we can increase here. You can take number of instances here. Suppose we are going to create 4 instances. You can also align it at an angle. You can see. Let it be 0 degrees. And there is a direction 2. In direction 2, perpendicular to the direction that we have selected, you can create multiple number of rows. You can see. We will switch the axis. So you just have to experiment with these options. So it may be any software, you will have this tool and you have to find this tool. When I click on this OK, you can see very easily multiple objects I have formed. We'll see the application of this in the next example. But for now, this is the type of array that we want, which is rectangular array or pattern. In CATIA, let us delete this and create a rectangle. Something like this. We'll take a circle here. Now we'll go to insert, operations, and in transformation we have seen this rotate. Now we will see translate. And we'll select the object, which is this. We'll select the point. You can see. Here we can go for instances. How many instances you want? Suppose I want 4 instances. You can see. Let us make it 3 instances. And you can give a value here. I'll give maybe some 70 mm. Press on the enter key. Now you can position it. I'll position it here. You can see. Now this entire thing I can take and I'll go to insert, operation, transformation and translate. Maybe 3 instances or 2 instances. We'll take this as the reference point and move. You can see. You just have to give the dimension value. So just double click here and move this to keep it vertical and type a value, maybe some 70. Press on the enter key. The angle you have to define, I'll keep it perfectly vertical. And you can see very easily we have created multiple objects using the rectangular pattern tool. I am giving you the generic name, rectangular pattern, polar pattern, something like that. But in every software it will have its own name. Objective of that tool will be this, to create this type of arrangement. Now let's see the mirror tool. Let us create an object something like this. Now if you want a mirror image of this object to be created about this vertical line or vertical axis on the other side, or I can take any line, maybe something like this, and I want to create the mirror image of this object on the other side. So what I'll do is I'll go to operations, transformations. Here I have this mirror. Click on mirror, select the object which is this, and then select the mirroring line. And you can see this object is exactly the mirror image of this object. Let us go to Solidworks and see how actually it is made. Now I will take this line tool and create an object something like this. You can see, and also I'll create a line, maybe something like this. Press on the escape key. Now let us find where is the mirror tool. Here mirror tool will always be nearer to the rectangular pattern, polar pattern tool. So we have used this linear sketch pattern earlier, and nearby to that you can see mirror entities. You can also see a preview of what it can do. Click on mirror entities. Now you just have to select the object which is this, and then mirror about this object, or so to say axis. Click on OK, and you can see what has formed. So how is it useful? Mirror tool is very useful for creating symmetrical objects. Suppose I am having an object something like this, the same object that we have created earlier, you can see, and there is an axis. Maybe this is the axis. Let this be construction element. So my objective is half of this has been created. I have to create other half of it. So we will go for mirror entities, select this objects. Now mirror about this object. Click on OK. Very easily we have created the other side. Now in CATIA also we will have the same application. Let us delete this, and maybe suppose I will create this kind of a feature, the same type of feature that I have created in Solidworks. Press on the escape key. Here the axis is not required to be created because we already have this axis here. Now we'll go to insert, operation, transformation, and mirror. Select this object and select the axis, and you can see directly we have created the other half. So you just create one half of the sketch, and the other half you can create instantly by using the mirror tool. That is the power of duplication. In the next lecture we are going to see the application of the duplication tools by using example 11.5. In this lecture, we are going to practice on example 11.5. We are going to see the application of duplication tools in this example. If you get a complex drawing, no matter how complex it may be, you should always go for making the boundary first, and then you are going to create the internal objects. Then only your approach will be perfect, and you can do the drawing easily. Like suppose we have got this 11.5 example. Here in this drawing what we will do is, first we will create this outer boundary. You can see this outer boundary first we are going to create, and then we are going to create these internal objects. While creating this internal object also, we are going to create one by one. Suppose we are going to create this thing first, and then we are going to create this, and we are going to create this circle, then this circle, and at last we can create this circle. So we are going step by step. That is the process that you should adopt while creating complicated figures. Let us start this drawing in CATIA and Solidworks. Now at first we are going to generate this outer boundary as I have told you. So let us see the dimensions associated with it. This outer boundary is a collection of an arc and some lines, another arc and some lines here. Now what we are going to do is, boundary also we are going to create step by step. First, we are going to take a circle here and constrain it. Then another circle, a bigger circle here and constrain it. Then we are going to create these lines. Let us start and you can see what I am talking about. Here you have to note that at this point there are a lot of references. You can see, taking this as center point, all the arcs have been generated. So this point will be considered as our main reference center point. This we will make it as 0, 0 or the origin of the coordinate system. Here in CATIA, this is the coordinate system. So in this origin, we are going to set this point. Let us start by generating first this circle. It is a R20 circle. So let us do it. We'll take circle tool here. Directly we can click on the origin. You can see. In any software you can click the origin directly. It will be available for you to select. I'll just click here and create the circle. No need to constrain the center point of the circle because it is automatically coincided with the origin. Now let us give the dimension. The radius is given as 20. The circle is completely constrained. Now we will take another circle. Again we will take this origin as the center point. You can see. Now this circle has been given a radius of 100. Let us take this radius as 100. The circle is also completely constrained. Now we will draw these two lines. You can see this line is tangent to the smaller circle and it is having a connection with this bigger circle. Let us draw a rough sketch of that. You can see I can create a point on this circle, but if you are not able to do it, you can create it outside. So now let me create a vertical line and then I'll move over here and you can see this is a auto constraint. It's a tangency that is getting formed which we require. You can use that or you can click somewhere else, maybe here. And we can give the constraints. We'll select this, use the control key for multiple selection and select this circle. We will give tangency. Now let us trim the unnecessary portions. So we will take quick trim this, again quick trim and trim this. Now let us constrain this profile. For constraining that we have some dimensions that have been given here. This length is 20 and from this edge to the center the dimension is 80. So let us give that. From here to this center the dimension is 80 and the length of this line is given as 20. You can see it is completely constrained. So we are going step by step. No need to make the entire thing and get confused. We will go step by step so that it is very easy to make any complex figure. Now we will go for a duplication tool, which is mirror. The same feature we require on the other side. If you see the drawing here, the same thing we require on the other side. So we will select this You can select these two and we will go for insert, operation, transformation and mirror that we have seen in the earlier lecture. We'll select mirror. Now what we have to do? If you are not clear, you can just have a look at the tip that is showing. Select the line or axis from which the elements will remain equidistant. So, it is asking for the axis about which we are going to mirror, or the mirroring line. This is the mirroring line. You can see. Very easily the other side has been made. Otherwise again we have to go for creating that and constraining. It's not required because we have mirror with us. Now let's go for trimming the unnecessary portions. Double click on quick trim to lock it and we will trim this portion and this portion. You can see we have created a completely constrained boundary. The same thing let us create in Solidworks so that we can compare with the procedure. Now this is the sketcher interface of Solidworks. Let us create the same outer boundary. We will take circle and directly we can select, you can see, we can select the origin and create a circle here. Let us create the origin again and create another bigger circle. So at a time we are creating two circles. Now let us give the dimensions. We'll take smart dimensions. The radius of this circle is 20. So we can give 40 here. Again, this bigger circle we can give a diameter of 100 is the radius. So 200 diameter we can give. And you can see both of the circles are completely constrained, which are denoted by this black color. Now let us go for the two lines. So we will take this line tool and create a line which is a vertical line. Here also there are auto constraints. You can see a tangency constraint is getting formed. But we won't do that. You can create auto constraints once you are perfect with the software. Otherwise don't handle auto constraint. It may be quite dangerous for your drawing. Select this line and this circle and between them we can give tangency. Now let us take trim entities, trim this and trim this portion, which are the unnecessary portion. Let us give the dimensions. We'll take smart dimension. We can give dimension to this line which is of 20 mm and again from this line to this point, that is the origin point, the dimension is given as 80. You can see. So here also we are going step by step. The procedure is same that you have to identify. In CATIA, whatever procedure we are using, in SolidWorks also the same procedure we are using. Only the method of use of the tool may vary, but the procedure is same. So that is the technique that you should follow. Now we will go for the other side. So do you remember how we had created the other side in CATIA? It was by using mirror. So here also we will take mirror entities which we have seen in the earlier lecture. Now here entities to mirror. You will get the words like entities, object, curves, which are signifying a single thing, which is this objects here. Entities means this objects. Objects means this objects. Even curves means this objects. So in different software the word may be different, but what it means is you want to select the things that you want to mirror about a center line or about a mirroring line. So entities to mirror this line and this line. These two are the objects or the entities. Now I'll click here mirror about. Mirror about, we have to select the mirroring line. But here there is no mirroring line. So what we will do is we can select this right plane. When you select here, as this property manager is active, so if you want to activate this feature manager design tree, it will come over here. So we can select this right plane. You can see we just have to select an axis or a mirroring plane or line. Now just click on OK and you can see Very easily we have formed the other side. Now let us go for trimming the entities. Click on trim entities. We will trim the unnecessary portion, which are these two. And you can see we have successfully formed the boundary. Now let us go for the internal stuff. Here you can see this is a rectangular array or linear array or linear pattern or rectangular pattern. All these words or any combination of this word means the same. This is the type of feature that we want to create by using that option. Let us go and create that. So for this, first we need to create a single circle and constrain it so that with its reference all the other circles will be made. Let us go for Solidworks and create that circle. We will create this circle first. This is a diameter 5 circle and it is positioned at 20 mm from this center. And also it is aligned to the x-axis. So let us do it. We'll take circle and create a circle somewhere here. Let us immediately give its dimension. First, let us give this dimension as diameter 5, which is given in the drawing. Let us zoom in a bit so that we can see it. Now, for constraining it, we have to give the dimensions. You can create a construction element, that is a construction line. I'll take from this center to this center. We can create a construction line. Press on the escape key to exit from the command. This line, I will make it horizontal and immediately I'll convert this into a construction element. Select this and construction geometry. Now let us give the dimension. This dimension is given as, let us see the drawing, 20 mm. You can see from here to here. This is 20 mm. So we will give this dimension as 20. And you can see the circle is completely constrained. Let us go for the other circles here. For that we will use the array tool or the pattern tool. But let us count. 1, 2, 3, 4. Total 5 number of holes are there along this horizontal and 3 number of holes are there in the vertical. So that is the set of array that we want. So here we can go for this linear sketch pattern. Select the object that we want to create as a pattern. Here we can select the number of objects. So there are 5 number of objects here. Let us see the drawing again. You can see 5 holes total are there. So here we can see a preview of it. Next, in this second direction, this is direction 2. There are total 3 rows. This is the thing that we want. Now just click on OK. But before that, you have to see the spacing. Now, if you see the drawing here, the spacing is 10 mm. That is, from hole to hole, the spacing is 10 mm. So let us see. Here this is the dimension. Along x-axis, that is along this direction, from hole to hole or circle to circle, the dimension is 10 mm, which is given in the drawing. And along this row, the dimension is also 10 mm. This is the 10 mm. So row to row dimension is 10 mm. In the direction 2, which is upwards, this is direction 2. This is the dimension, which is 10 mm. So we'll just click on OK and you can see very easily we have formed this rectangular pattern or linear sketch pattern, which is called in Solidworks. Let us move to CATIA and create this. In CATIA, we have the same tool but in a different name. First, let us create the circle that we had created in Solidworks. This is the first circle, so that the reference of this circle we will use for creating the other circles. We'll give the dimension. The diameter is 5 mm, so we will change here to diameter. It is 5 mm. And let us position it. We'll select the circle center. Use the control key for multiple selection and select the horizontal axis. Now we can coincide this. Click on OK. Let us give the dimension from this center to this axis, which is given as 20 mm. Now let us create the array or the pattern. Here in CATIA, it is given in a different name. In transformation, there is translate. Click on translate and we will select our object, which is this circle. Select the reference point within the object. We will select this center point and you can see we are able to form some duplicates. Total 5 number of duplicates are there. So another 4 I will create. You can see we can give the dimension here, which is 10 mm. So 1010. Press on the enter key and now you have to position it. I will position it horizontally. You can see. You can mark here that it is not getting constrained. So it may happen in few softwares that when you use duplication tools, the duplicates may not have the constraints that are there in the original object. It doesn't matter because those objects have been positioned with reference to the original object. So we can just ignore it. Let them be unconstrained. It doesn't matter as long as they are positioned perfectly. Now let us go for the other 2 rows. We will take translate again, which is this icon, and another 2 instances we want. We will select the object. This is the object. Reference point is the center and you can see along this direction also from center to center, or so to say the circle to circle, the distance is 10 mm. So we can give a value here as 10, enter. And now we can position the circles. We'll position it vertically and you can see we have formed the set of holes. In Solidworks, we have seen how to hide and unhide. There are few reference lines that have been formed while we have formed the array or the pattern. We can hide this. We have to find the hide and show icon. So you can just move over to the left top corner and from there we can have a look. These are all file saving and related options. And here these are the view toolbar, and the hide and show will mostly be there in the view toolbar. So here if you move along this direction, here you can find this hide and show. You can see. So if you click here, this gets activated and you can select. You can see it is hidden. Now when you select this and also select this hide show, you can see. Now for unhiding, you can use this side icon. This is swap visible space. Click on this. This is the hidden space in CATIA. And if you click it again, this is the visible space. So whatever is hidden in this visible space, you will get it in this invisible space. So if you want to unhide, you can again go for selecting this hide and show and clicking on this line. You can see it is now displayed in the visible space. So let me hide it again. Now let us make this set of circles. For making this set of circles, of course we require a single circle first. So we will create this circle. Now to constrain this circle, first we need the diameter, which is given here, dia 8, and we require the position. For position, we have this radius R55, that is from the center, and we have this angle. It is 90 degrees. So from center, it is 45 degrees. Let us create it. Let us create a circle here. Prevent this unnecessary constraints. Otherwise, it will create problem. Now let us give the diameter first. The diameter is given as 8 mm. And next what we can do is, we will take a line from the center to this origin. We can connect this line, and this line will make it as construction element. Now we will just give the dimensions. We'll create the angle between this line, construction line, and this axis. You can see This angle is 90 divided by 2. 90 divided by 2, which is 45. You can see. And also we have the dimension from the origin to this center point. We can give the dimension here directly to this line. The radius is 55. So we can type 55 here. And you can see the circle has been constrained. Now our job is to just create the other duplicates of this circle. So for doing that in CATIA, we have a tool. We'll go to Operation, Transformation and Rotate. Click on Rotate. Select this object that we want to rotate. Now we have to select the center of rotation, which is this origin, and the reference of the object, which is this. You can see. Now how many you want? Let us count it. 1, 2, 3, 4, 5. 5 more holes we require. So here we can increase it to 5. You can see here. And then what about the angle? We can give an angle here. Also click this constraint conservation on. So whatever constraints are given, that will be copied to the new objects. Well, few of them, not all of them. So whatever is possible, let us copy. Now we will give an angle here. Let us see what is the angle. When you see here, this total is 90 degrees. So in 90 degrees, the entire spread is there. So the objects are 6. So 90 divided by 5 is the angle. So we can go for 90 divided by 5. Enter. It has formed on the other side. So let us undo. And again we will go for rotation. This circle, we will take this as the rotation center. And this is the reference of the circle. And here we can go for minus 90 divided by 5. Press on the enter key. And you can see we have formed the required duplicates of this original circle. The same thing let us do in Solidworks. Let us create the circle first. A single circle. You can see. Let us give the dimension. The diameter of this is given as 8. Now let us position the circle. We will take a line and connect the center of this smaller circle to the origin of the drawing. Press on the escape key to exit from the command. Now we will immediately convert this line to construction element. You can see. Now let us unhide this right plane. So we can click here show and we can take the smart dimensions from this line to this plane. The dimension is 45. 90 divided by 2, which is 45. Also, the dimension of this line is the radius, which is 55. You can see. The circle is completely constrained. Now we can go for circular sketch pattern. Select this circle that we want to create as a pattern, and now you can see how it is getting formed. We don't want like this. By default, the origin has been selected as the point of rotation. So that is what we want. But if you want, you can select it. Here we can go for dimension angular spacing. So we can go for a dimension 90 divided by 5. And we can see a preview. The number of total objects that we want to create is 6. You can see here, this is 6. So we will give a value here 6. You can see the preview. It's perfect. So we will just go for OK. And you can see it has formed. Let us hide this right plane. Now let us go for the other things. Here we have a circle here and a circle here. So one circle we will create and the other circle we will mirror. So for this circle, you can see it is positioned at 45 degrees from the center. That is 90 divided by 2. Let us create the circle first. We'll take circle We'll create a circle here, and what we will do is, as this is 45 degrees, we can take this line and use the control key for multiple selection. Select the center of this circle and we can go for coincide. Now we can give the dimension. First let us give the diameter. The diameter has been given as 20. Let us give the dimension here 20, enter, and let us take the dimension from this center to this origin. This dimension in the drawing it is given as, here you can see, this is R80. So the length of center to center is 80. So here we can give 80, enter. Now the same thing we can create on the other side. We can do it at a time with the other circles, but let us do it immediately. We will take mirror entities, select this, and we want to mirror it about the center plane. So the center plane is not available. We can go to feature manager here, and this is the right plane which will act as a mirroring plane. Click on this. Click on this OK, and you can see very easily the other side has been formed. Let us go to CATIA and do it. We'll take circle. We'll create a circle here. As this construction element is on, that's why it is creating a dotted object, but we can click it off. You can see now it is solid. Select this center of the circle and this line. The same procedure we are adopting, so you just compare the procedure. Now we'll take dimension from the center to this origin. So this dimension is 80, enter. Now let us give the diameter. The diameter is 20. You can see. Now we will use the mirror. So select this circle, and here we have the mirror here. Click on mirror. Select the center axis. Very easily we have formed the other side. Now let's go for the other circle. Here we will form this circle. Between these two circles the dimension is 30 degrees. So from the center axis it is 15 degrees. And the diameter is 16 mm. So let us create a circle first. Let us give the diameter to this, which is 16. Let us take a line from the center to the origin. You can see. Now I'll select this and convert it to reference because it is a construction element. Let us give the angle between this line and the vertical axis, which is this. We'll give this a value of 15 mm because it is 30 divided by 2, 15. Let us give the dimension to this line, which is center to center distance. Here, if you take this, it is 80 mm. So the center to center distance is 80. 80, enter. Now we just have to take this circle and use mirror. Select the mirroring line, which is this. And you can see very easily we have formed the other side circle. Now we are left out with only this center circle. We'll take a circle here, create a circle something like this. We'll switch off this construction element. Now we'll take this center, use the control key for multiple selection, and we'll select the center axis, that is the vertical axis, and we will use coincidence. Let us see the drawing. Here, this is 12 mm diameter and the position is also at 80 mm from the center. Let us give that. First we'll give the diameter, which is 12 mm. And next we will go for the center to center dimension. You can see from center to this axis the dimension is 80. We could have also gone for creating an arc which will act as the pitch circle, and we can give the dimension as 80 radius, and all these holes we could have positioned there. But there are various ways of making the sketch. Whichever you find it is easy, you can do. Now let us go for Solidworks and create those two circles and the center circle to complete the sketch. In Solidworks also we will use the same process, but let us give it a change. You have seen the process that we have adopted in CATIA, and I have told you we can also use an arc. Let us go for the arc and create the pitch circle and position the circles, and let us see the process. To draw an arc, you can find out the arc tool here. You can see here, this is center point arc. We can take 3-point arc here. Click on 3-point arc. First point, and maybe the second point is somewhere here. And the third point, let us position it here. We can go for constraining. We'll select this arc and use the control key for multiple selection and select this arc. Both of this arc we can go for concentricity. You can see this has been converted into black. Now just select this and go for construction geometry. We can create it concentric, or we can also give the radius as 80, which is given in the drawing. Now let us generate the circle. We'll create a circle maybe somewhere here, and we will go for constraining it. We'll select this center of the circle, use the control key for multiple selection, select this arc, and we can go for coincident. Now let us position it. We'll take this center point and we'll take this point, which is the origin. Now let us take smart dimension, and from this line to this right plane will give an angle. This angle is 30 divided by 2, which is 15. You can see. Now we'll give the diameter of this circle. This diameter is 16 mm. 16, enter. Now if you see, it is not constrained. Let us first convert this into reference. So we'll use this construction geometry. Now when I move this, you can see the pattern is also changing, because the pattern is not completely constrained. So we are okay with if the pattern is not constrained, but the thing is this line should be completely constrained. So let us place the pattern something like this, and we will take this point and this origin point, and we will go for merge. You can see now it is completely constrained. Let's go for the other side. We'll go for mirror entities and select the entities to mirror, which is this, and we will select the mirror about as the center axis, which is this right plane. Now we are left out with only this circle over here. So directly we can take circle and we can position it here. You can see this is the midpoint of the arc. We can take this midpoint of the arc. Now we'll use smart dimensions to give this diameter as 12 mm. So with this we have completed the fully constrained geometry of example 11.5. Now you can see here the process that we have adopted in both the softwares. It is exactly the same. Only the difference is the name of the tools that have been used, and maybe there is slight change in the way the tool is used. the main framework is same. So you must understand the framework, and the same exact procedure you can use in any type of other software. You are now ready to explore the solid modeling application. So in the next lecture, we are going to get into solid modeling. From this lecture, we are going to get into the solid modeling application of any CAD software. There are few steps that you should follow while entering into the solid modeling application. The first step is, do you remember we had created a rectangle of 100 into 50 mm? So we will open the rectangle file that we have saved in our desktop. We have to find the solid modeling application icon and we will launch it. We will explore and find the extrude tool which is used for creating solid model. We will see what is it. Then we will use the rectangle to create a solid body using the extrude tool. And finally we will explore the extrude dialog box. Now here you can see we are in the gateway of CATIA. We will go to File, New, and we are going to create a part. Now, as per the steps that I have told you, first we have to open the rectangle that we have saved in our desktop. So we'll go to File, Open, and in the desktop we have our file here, rectangle. Click on Open. This is the rectangle file that we have created. Let us open the same rectangle in Solidworks. We'll go to Open, and in desktop we have the rectangle here. Click on Open and you can see this is the rectangle. Now this is the isometric view that we have discussed earlier. In Solidworks, if you click here, this is the isometric view. You can see. Now we have to find the solid modeling application icon and launch it. But in most of the softwares, when you exit the sketch, let me double click on this sketch. Now we are in the sketcher interface. When you exit this sketch, so what you are doing is, you are exiting the sketch application of the software and you are getting into the solid modeling application. So some softwares may require you to select the solid modeling application, but in most of the softwares, when you exit the workbench, that is the sketch workbench or the application, it will take you to the solid modeling application. So you need not search the solid modeling application. By default, when you exit sketch, you will be presented with the solid modeling application. But in some softwares, you may have to select the solid modeling application. Now we have to find the extrude tool. Let us explore and see where the extrude tool is. An extrude tool will add material to this sketch to form a solid body. The material will be added linearly, like a building block. Let us see what is that, then you will understand. Here, these are the tabs in Solidworks, which represent various applications. Here in the first tab, this ribbon contains the solid making tools. And the first one, you can see this is extruded boss or base. And you can see the preview what it does. You can see in this way it can create a solid. Let us check it out. Click on this extruded boss and let us select this sketch. And you can see solid is getting built on the rectangle. Here you can give the distance. You can see, suppose 50 mm or 40 mm, and when you click on OK, you can see a solid has developed. This base dimension is taken from the rectangle that we have created, that is 100 into 50, and this height we have given in the extrude definition dialog box. Now let us move to CATIA. Here also we have this same rectangle, and let us find the extrude tool. This is the part design interface. That is the solid modeling interface of CATIA. Now let us find the solid making tool. Here in the sketch based features, there are various things. So few things are de-highlighted and few things are highlighted. The very first one is pad. You have to study the icon and understand what it can do. Do you remember in Solidworks we have created a rectangle and we have extruded. So that same type of object we can see here. So this may be the extrude or the solid making feature. We'll click on this pad and here we have this pad definition dialog box, but basically we require to select the sketch first. So this is the sketch and you can see a preview is shown that something is getting formed. Let us give this length maybe some 40. When we see this preview, click on preview, you can see a solid object is getting formed. Now click on OK. The block has been formed. The same block that we have formed in Solidworks. So the procedure is exactly the same. There is no difference. Till now we were working in a single sketch. So we were not using this part navigator or the tree. In this part navigator, it will contain various things. But what we are interested in is, if you click here, you can see we have a sketch which is this rectangle, and upon that a boss extrude has been created. So this navigator will store all the history of the things that we have done with our model. When we create the model and use different type of features, then you will understand this. But for now, if you want to edit this object, you just have to select this boss, right click, and here we get this edit feature. Or sometimes you can also double click on this. In some softwares it will work and in some softwares it may not work. Also you can double click on this object. In Solidworks it doesn't work, but you can go for boss extrude, right click, and here you can select edit feature. You can see this is the same window that we have got, and here we can change the dimensions. So at any point of time, if you want to change the dimension, you can change. Here there is also a direction too. When you click this, you can see this is a separate direction that is shown. So in the top it will be 40 mm and in the bottom you can give a separate dimension. This option is very handy, so you should know it. You can also give a minus value to this. Now here there will be an option from. We can take here offset and we can give a dimension here. Let us switch this off so that only one direction we will have and we can see how this works. In offset, let us give some 10 mm and see what happens. You can see from the sketch plane the solid is forming at a distance. This is also very useful. So 3 things I have shown you. The other things you forget. 3 things I have shown you. First, in the direction 1 we can give a distance. Second, in direction 2 also we can give a distance. And in third, we can give a offset. That is, we can start at a distance from the sketch plane. These 3 features are very important for a extrude. We will see the application part of it in the next example, but for now, these 3 features we have to learn in any software at the starting itself. When you click on this OK, you can see the solid has formed. Now the same features I will show in CATIA. In CATIA, you can just double click and the dialog box will appear. The same thing you can see in this part navigator. And here when you click on this plus, you can see pad and sketch. The sketch we have created, which is the rectangle, and then upon it we are creating a pad. So these 2 are related. Now if you see here the length we have given. When you click on this more, you can see there is a second limit. So this is the second direction. If I give a value of some 30, let us see what happens. We'll click on preview. You can see. So from the sketch plane or the sketch, 40 mm is created up, and from the sketch plane 30 mm is created down. Now this is the second thing that I had shown you in SolidWorks. And the third feature that we want to learn is the offset feature, which is there in SolidWorks. The same thing will be there here, but we have to explore and find out. I'll show you directly so that you can correlate with SolidWorks. Here in second limit, we can give a value of minus. When you give minus and show the preview, you can see. So here if you take minus, then it is starting from 30 mm and ending at 40 mm. So this thickness is 10 mm. We can give a 10 mm here. We'll go for preview and you can see. At 10 mm it is starting and 40 mm up to 40 mm it is going. So the total thickness is 30 mm. So this feature is very useful in generating 3D models. In the next lecture, we are going to see the example, which will have all these options used in the extrude for the model. There is also another thing that you should learn. This is creating a solid, but how to cut it? Suppose I want to cut some portion of this block. Let me select this upper plane and create a sketch. You can see. Now let us create another rectangle, maybe something like this. We'll exit the workbench. You can see I have created a sketch on this top plane. So instead of selecting only the datum plane, we can also go for selecting the plane of the solids. Now I'll go for this pad. When you click this, you can also go for reverse direction. You can see. When you click on OK, it is creating a solid body, but we want to remove the material from the solid body. So we will go for Ctrl Z. There is a thing called the Boolean operation. Boolean operations are used for adding, subtracting, intersecting material from a solid body. So here, this is a solid body that we have already made. Now we are creating another solid body using this sketch, and we are giving a relation between both the solid bodies. That is, do you want to remove the new solid body that you have created from the existing solid body, or do you want to unite it? By default, when you use pad in CATIA, it is uniting the solid body. But what we want is, we want to remove the new solid body from the older one. So for that, we have to find the subtract Boolean operation. In most of the softwares, those are automatically generated by the extrude tool. But in CATIA, we have a separate option for it. If you go to insert and sketch based features, now you can see all the tools have been highlighted. This is pad and this is pocket. This is drafted fileted pad and pocket. Shaft, groove. So in CATIA, what has happened is, they have created one tool for adding material and one tool for subtracting material. So this is for adding material linearly, and here this is for adding material, subtracting material, adding, subtracting, adding, subtracting. So they have been arranged something like that. So you have to study the interface of the solid modeling workbench. Then only you will understand what tools are available and how you can apply it. Now we will go for pocket and select this sketch. Click on OK, and you can see this is what we want. We have cut the material from this solid body. Let us do this same exercise in SolidWorks. You can see here. Let us take sketch. We'll take this sketch on this top plane. By default it is not orienting, so we can click here and we can click normal too, and we can see the plane that we have selected. Now let's take a rectangle and create a rectangle something like this, the same rectangle that we have created in CATIA. Now let's exit sketch. Now let us cut this new body from the existing body. We'll go to features. Let us see here what are the options that are present. This is extruded boss or base, revolved boss or base, swept boss or base. So everywhere boss or base is. Then when we move over here, there is extruded cut, hole, revolved cut. So what this means is, this entire thing is for adding material, and this cut, this means this is for removing material. So we have to use this extruded cut. Click on this extruded cut and select the sketch, which is this. You can see something is happening. When you click on this OK, you can see the new object has cut the existing object. So these few tools are very important. In the next lecture, we are going to practice solid modeling on example. We'll see example 1.2. In this lecture, we are going to practice on example 1.2. We are going to apply whatever we have learnt in the last lecture. While creating a solid model, it is very important that you should understand how you are going to create it step by step. First, let me create this solid model so that you will understand what I am talking about. This is the solid model that we are going to make. You can see the dimensions here. First, let us create this base. I'll go to CATIA and create a new file. I'll go to File, New, and I'll go for Part. We are going to create a new part. Now, the very first thing that we have to do is create a sketch. The sketch will contain the base of this body, which is something like this. Let us see. Let us create a rough sketch. We'll click here and here. Now let us constrain it. We'll align these two by using coincide. Then again align these two by using coincidence. Now let us give the dimensions. This is 25, this is 15. This is 25, and here this is 75, and this edge is 45. This edge is 75 and this edge is 45. You can see the sketch is completely constrained, and that's it. We only require this sketch. We will not make the other profile in this sketch. Let us exit the workbench. Now let us go for creating the solid body. We'll use this pad that we have seen in the last lecture and select the sketch. Let us give the thickness. The thickness is 15 mm. Here we will give a thickness of 15 mm. Click on OK. The very first solid we have formed, which is representing the base. You can see this is the base that we have created. Now the same thing we will create in Solidworks. Let us create a new file, new part, and we'll go to sketch. Let us create a sketch on this top plane. We'll create a rough sketch the same rough sketch that we have created in CATIA. It is just a collection of horizontal and vertical lines. Now we will apply the constraints. We'll use the geometrical constraints. This point, which is the origin, will lie on this line. You can see. Again, this line will contain this origin. So, coincidence. Now, we'll give the dimensions. We'll activate the smart dimensions and let us give the dimensions here. This dimension is 25 and this dimension is 15. This dimension has been given as 75 and this dimension has been given as 45. Now just exit the sketch. You can see the sketch is ready. Now let us move over to features, extruded boss. We'll select it and now select the sketch. You have to just feed the distance here. The thickness is 15. So we will give a value of 15 here. Now press on the enter key and click on OK. You can see we have created the first solid body in Solidworks. Now on this solid body we are going to create the other features. The very first feature that we are going to create is this cut. This is 8 mm depth and a rectangular cut on this base. So let us do it. First, let us select this top plane. We'll take sketch, select sketch, select this top plane and here we will go for normal to so that we will view the sketch plane. Now let us create the rectangle. We'll make a rectangle. Let us constrain it by giving the dimensions. Here you can see this is 35 and this is 25. Let us give it. We'll take smart dimension from this edge to this line. This is 35 and this length is 25. Now let us see the other dimension. Here from this base it is 20 and this dimension is also 20. So from this base to this line, this dimension is 20. Also this length is 20. So you can see the rectangle is completely constrained. We will go for exit sketch. We'll rotate this a bit. You can see. Now we will go for features and here extrude cut. Select the sketch. You can see by default it is moving down. Now up to what depth you want to cut, that we have to identify. This is 8 mm depth. So up to 8 mm we have to cut this body. So here we will give 8 and click on OK. You can see. Let us create the same thing in CATIA and see what difference are there. We'll take sketch on this plane, that is the top plane of the base, and we will select this rectangle, create a rectangle something like this. Double click on dimensioning. From here to here we have given a dimension 35 mm. This length we had given a dimension 25. From this base to this line the dimension is 20 and this length is given as 20. With this you can see the sketch is completely constrained, indicated by the green color. Now you just exit workbench. You can see the rectangle has been made. Now let us take the solid editing feature which is cut. This is pocket. You can also go to insert, sketch based features and pocket. click on pocket, select the sketch. You can see it is cutting the body. Here we will give a dimension. The depth has been given as 8 mm. So we'll give a value 8 here. Let us see the preview. You can see this is what we want. Click on OK. You can see. So the procedure of making the features is same in all softwares. Only the utilization of the tool is a bit different. That you can easily identify if you know the procedure. Now let us move to the other features that are contained in this drawing. Here we have this rectangular block and there is a triangular element here. So let us create this rectangular block first. For doing that, we will take sketch and again we will take this top plane. And we will create a rectangle, something like this. Now we will take this line, use the control key for multiple selection. We will coincide these two. Click on OK. Again we will coincide this and this edge. Now let us give the dimensions. Here if you see the drawing, this is 15 mm and this is 40 mm. Let us give the dimensions here. This is 15 mm and this length is 40 mm. The sketch is completely constrained. Let us exit the workbench and now we will use pad because it is adding material. We'll use pad, select this sketch and let us give a dimension. The height is given as 30. So we'll make an object of 30 mm length. You can see 30 mm. The same thing let us create in Solidworks. We will take sketch, select sketch here and we'll take this top plane. Here we can take this normal to and we'll take this rectangle, create a rectangle something like this. Now let us constrain it. Let us first take this line, use the control key for multiple selection and select this edge. And we will go for collinearity. Again, we'll take this line and use the control key for multiple selection, select the edge of the solid. Collinearity. Now let us give the dimensions. Use smart dimension and give a dimension to this line. We had given a value of 15 here and to this line we had given a value of 40. Enter. You can see the sketch is completely constrained. Now let us exit sketch. You can see here we have made the sketch on the top of this base. Now let us create the solid body from this sketch. We'll go to features, extruded boss because we want to add the material. The sketch had already been selected, so it has directly made the solid body. Here we'll give a dimension to this. We had given 30 mm as given in the drawing. You can see a preview. Now click on OK and you can see. This is what we wanted. Now let us take sketch again and we will take this plane and create the triangle. Let us see the drawing. Here we want to create this triangle here. So let us make it. We'll take sketch and we'll take this plane. Here we'll take this normal to so that we can view the sketch plane. We'll take line and create a triangle, something like this. Now let us constrain it. We'll take this line, use the control key for multiple selection and this edge. And we will go for collinearity. Similarly, this line and this edge, and we will go for collinearity again. Now let us give the dimensions. In the drawing you can see here, this height is 22 and angle is 50 degrees. Let us give that. First let us give the angle between these two lines. The angle is 50 and this length is given as 22. You can see the sketch is completely constrained. Now we will exit the sketch and you can see the triangle has been made on this face, but our object should be in this area. So how are we going to use this sketch to create the object somewhere here? By the use of options that are present inside the extrude. You can see this extruded boss. I'll click here. The sketch had already been selected, so it has directly taken. Otherwise, you can select the sketch. Now, this extrude is forming on the other side. We want it on this side. It is forming on the right side. We want it on the left side. For doing that, there will be an option for changing the direction. Here, there are some arrows. So, this is the reverse direction. When you click, you can see it is changing the direction. This is what we want. Now, if you see the drawing here, this feature is starting at 15 mm and it is continuing 10 mm. So let us give the dimensions to our extrude. Here, we will give this offset. It is starting at 15 mm. Click here to see the preview. So here the offset has been taken on the other side. Here also there will be a direction change. You can see here, this is the direction change. Or you can also attempt for giving a -15 value, which doesn't work in Solidworks, but it may work in some other softwares. At a distance of 15 mm from the sketch plane, the object has extruded. Now, this dimension we will give as 10 mm. You can see, this is what we want. At 15 mm it starts and it continues up to 10 mm. And you can see, our object is complete. Now let us do that in CATIA. Here also, we will take the same plane, which is this, and we will generate a sketch. We'll use profile and create a triangle, something like this. This is a horizontal line. We can track the endpoint and connect it with a vertical line. Now, take this vertical line, use the Control key for multiple selection, select this edge, and we can go for coincide. We'll take this line and this edge, and we will go for coincide. Now, the dimensions had been given. Do you remember? I'll use the dimensional constraints and give the angle here. The angle had been given as 50 degrees and this length we had been given as 22 mm. The sketch is completely constrained. Now we will exit the workbench. Now we will use this pad and select this sketch. Now this extrude or the pad is forming on the right side. We want it on the left side. So we will go for this reverse direction. So you can see the tools are same. The work of the tools are same. It is present in all the softwares. But you need to know the application of the tool. That is the thing that I am teaching you. You can see the procedure that I am adopting. For Solidworks, I have used the same procedure that I am now using in CATIA. Only the use of the tools is different. There we had an icon for reverse direction and here we have a button. You can just select it and it will work to reverse the direction of the object's extrude. Now let's click on more. And here in this length, we will give a value 15 because I had told you in SolidWorks that the extrusion or the pad is starting at 15 and ending to a value of 10. So here I will give a value 15 and see. I'll give 15 and see a preview. The 15 is forming on the other side. We want it on the left side. There is no reverse direction. So here we will give some minus 15 and see what happens. We'll go for preview. Yeah, this is what we want. So you have to experiment and know how the things are forming, and then you can apply your dimensions. This total length, if you see here, from this plane, the entire length is 30. Again, from this plane, this is 15. So if you want to give 10 mm here, so it should be 15 plus 10 mm, 25. So here we can give a value of 25. You can see a preview. This is what we want. Now click on OK. And you can see we have completed the model. In this entire course, I am giving stress on the technique. This is what I am saying. You can see what technique I am talking about. The procedure and the technique that I have used for creating the model is same in SolidWorks and CATIA. Only the use of the tool is different. Even the tool has options and the functions which are very similar, or so to say, it is same. Only you have to find out where it is. In the next lecture, we are going to see another example. That is example 24. In this lecture, we are going to explore the solid corner dress-up tools, which are solid edge fillet and solid edge chamfer. So we are going to find these two tools and practice on a block. Let us see. In CATIA, I have made this. This is a normal block. The base is 100 into 50 and the height is 50. So you can make a cuboid something like this, and on this we will practice the solid corner editing tools, which are fillet and chamfer but in solid. Let us see. We'll go to insert. Here we have these dress up features, and here we can find edge fillet and chamfer. We will take edge fillet here. Click on edge fillet and we will select maybe this edge. We are selecting the edge of the solid. Now let us give a dimension. Maybe I'll give some 10 mm radius. Now click on OK. You can see this is a fillet, a solid edge fillet. Now let us see chamfer. We'll go to insert, dress up features and chamfer. We'll select this edge and we can give a length here, maybe some 10 mm and angle 45 degrees. Click on OK. You can see this is a chamfer and this is a fillet. Now let us go for chamfer again. Chamfer on this edge. Here we have two types of chamfer. One is length angle and other is length. Length angle already we have seen. We can give a length and we can define an angle. Let us define an angle as 60 degrees and see what happens. You can see here, this is longer and this is shorter. Here if you go for reverse, you can see the direction is changing. Let us go for this orientation. Click on OK. You can see a chamfer is getting formed. Now let us go for the other chamfer, that is distance. We'll select chamfer here and here we will go for length. Click on this edge, and on this edge I want to create a chamfer with length 10 mm and 20 mm. You can see the preview. You can also go for reverse here. Now click on OK and you can see. So this is how chamfer and fillets are given to a solid. Let us see this in Solidworks. Here in this SolidWorks, I have created this same cuboid that was there in CATIA. Now let us create the fillet. Let us find out where the fillet is. These are all solid creation tools. These are solid removing tools. And here we have a fillet. Let us click here. You can see fillet and chamfer both are here. I'll go for fillet and I'll select this edge. Here there are few options. If there is no preview, this won't be visible. We can go for full preview and here I can give a value, maybe some 10 mm. You can see the preview here. Just click on OK and you can see. There will be various types of fillets and chamfers. This is the basic fillet that we require. Other fillets are occasionally used, maybe 5% or 3% chance that it will be used in a drawing. Most of the time we will use this normal edge fillet. So you should be aware of this tool. Now let us go for chamfer. We'll take this edge and we'll go for chamfer. Select this edge. You can see the preview here, how the chamfer is getting formed. In CATIA we had angle distance and distance. Two options. Here also we will have angle distance and distance. In every software we have these two options. So you should master these two options. Now the first one is angle distance. Let us go for that. Here you can see distance is there and angle is there. So the distance is 20 mm and angle is maybe some 30 degrees, or I can give some 45 degrees. You can see. Let me give the distance as some 10 mm and we'll click on OK. You can see. This is a chamfer. Now let us go for other edge and create a different type of chamfer. Here we'll go for distance. You can take this and in distance also it will have two options. Here you can see symmetric and asymmetric. In symmetric, both the sides equal value of the length will be given. Suppose I give here 20. You can see both of this direction 20 has been given. Otherwise we can go for asymmetric, by using which we can give different distances. You can see here this side is 20 and this side is 10. So when you click on OK, the chamfer is getting formed. In the next lecture we are going to apply the chamfer and fillet on example 26. In this lecture we are going to practice example 26. First let us create our basic solid model and then we will apply the fillets and chamfers onto it. First we will create this top portion and then we will go for this bottom cylinder and then we will apply the holes. For creating this top portion we have this dimensions. R25 is the outer dimension and the center to center is 50. Let us create it. First let us select a plane, maybe I'll select this plane, and let us create a elongated hole. You can see elongated hole. I'll take this first point as the origin so that I did not position it. You can see. Now this dimension is the radius that has been given as R25. 25. Enter. And the center to center dimension has been given as 50. it is completely constrained. So now let us exit, and we will use pad and create a solid body of thickness. You can see this is 20 mm thick. So we will give a thickness of 20 mm. Click on OK. You can see. Now let us take the same plane and create another sketch. This time I'll create a hole and I'll take this origin as my hole center and give the circle a dimension of, you can see this is 40 diameter. So we will take diameter 40. Now exit the workbench and we can go for pad. We can reverse the direction and let us see what distance it has been given. This total is 100. We have created the sketch on this face. So 100 minus 20 will be our dimension from this face to this bottom face. So we will give 100 minus 20. Here, no need for calculation. You can give 100 minus 20. Now the same thing I'll create in Solidworks. Let us create a sketch on this top plane. And here also we have this straight slot. Click on straight slot. I'll select this origin point as my first circle center and I will create a straight slot, something like this. Now let us give the dimensions. I'll take smart dimension and we'll give this radius as 25. And next, this complete length we will give as 50. You can see the entire figure is constrained. Now we will just exit sketch and we will go for features, extruded boss. You can see along upward direction we will make a solid of thickness 20. You can see. Now I can take this plane and create a sketch here. We'll take circle and I'll select this center. Create a circle. Let us give the dimension. This dimension is diameter 40. Now exit sketch. You can see how we have created. Now in features, we will go for extruded boss. Select this sketch and we will give a dimension of 100 minus 20. So it is 80. And you can see. So you can see that the technique that we are using for creating the solid is same in CATIA and Solidworks. Only the tool has a different type of look and name. Otherwise the operation of the tool is also same. Now let us go for creating the holes. Here we have this counter bore. This outer dia is 32 and the inner dia is 10. You can see the radius is 10, so diameter is 20. Let us create this. We'll take sketch and we'll take this top plane. Now we'll take this center and create a circle here. This circle dimension is this diameter 32. Let us give the dimension. This is of diameter 32. Now let us exit the sketch and we'll go for features, extruded cut. This hole is up to a depth of 10. So we'll give a depth of 10 here. Now again we'll take sketch and we'll take this sketch icon. Create a sketch on this face. We can take this normal view and we'll create another circle here. Let us give the dimension. This diameter is 20. You can see here, this is radius 10. So the diameter is 20. 20, enter. Now let us exit the sketch. You can see where the circle has been formed. Now we can go for features, extruded cut. We can select this circle. And here we will go for through all. So it will cut everything on its way. Just click on OK. And you can see very easily we have formed this hole. But it will be further easy if we learn the hole tool in the further lectures. Now let us again go for sketch and select sketch on this face. Here we'll select normal view and we'll make a circle here. We'll select this circle and this edge. We'll make it concentric. Now we'll take smart dimensions. Let us give a value to this diameter. You can see this diameter is radius 15. So 30. 30, enter. Now let us exit the sketch. You can see. And directly we will take features, extruded cut, and here we will go for through all. So it will cut everything. Click on OK and you can see. Let us go to CATIA and form this same features. We'll take sketch here and I'll take this. We'll take circle and create a circle here. This diameter will be 32. Now exit the sketch. We'll create pocket. Select this sketch and this distance will be 10 mm. Now again we'll take sketch on this face. We'll create a circle. We'll take the origin as the center of the circle and let us give the diameter of this as 20. Now exit workbench. Again we'll use pocket. Reverse the direction and here we can go for up to last. So it will cut everything on its way. Click on OK and you can see. Now let us take sketch again on this face and we'll create another circle, something like this. Let us select this circle and this edge and we will go for concentricity. Now we'll give the dimension to this circle, diameter 30. Now exit workbench. We'll use this pocket and again we'll go for up to last. You can see here. Click on OK. And we have formed our solid. Now we will go for solid editing tools, that is chamfer and fillet. Let us study the drawing first. Here let me zoom in a bit so that you can know what dimensions have been given. Here you can see this chamfer 2 into 45 degrees. This is typical. So that indicates wherever there is a chamfer, it is 2 into 45 degrees. So the chamfer is there here, 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 here. Even here the chamfer is there. Here also there is a chamfer. Even here there is a chamfer. And here also there is a chamfer. So wherever there is a chamfer visible, the value is 2 into 45 degrees. Let us give the chamfer. We'll go to insert, dress of features, chamfer. Click on chamfer and here the value is 2 into 45 degrees. So we'll give the length as 2 mm and angle as 45 degrees. Now we will just select the objects that we need to chamfer. So we'll select this edge. Again we'll select this edge, this edge, this edge and this edge. Even this edge is also having a chamfer. Now just click on OK. And you can see in one shot all the chamfers have been given to the selected objects. Now let us give the same chamfer to the object in Solidworks. Here we will go for chamfer, and here angle and distance. The distance is 2 mm and the angle is 45 degrees. Now we just have to select the edges. We select this edge. Let us zoom. We'll select this edge, this, and in this direction we have this edge and this edge. Click on OK, and you can see in Solidworks also in one shot all the chamfers have been generated. You can see the generation process. It is exactly the same in Solidworks and CATIA. But if you apply this in any other software, it will work the same. So you should learn the technique and not the tool. Now we will take fillet here and we will give a dimension. Here we will give the radius as 5 mm, and now we just have to select the edges. Let us select this edge. We will select this edge. Automatically it is getting propagated. You can see. When you are applying fillet, don't select too many edges, otherwise it will create a problem. Here, if you see, we are going to apply a fillet on this edge also, but here in this corner there is going to be a problem. Do you want to see it? I'll show you. I'll select this edge. And you can see everything has disappeared. If I click on OK, some errors will come. Why these errors are coming? Because there is a conflict in this area. So here just remove the edge on which we don't want to create now. Right click here and delete. Only these two edges have been selected. Now go for OK. The fillet has been applied. Now I'll go for fillet again and apply on this edge. You can see the dimension value is 5. Now just click on OK. With this, the model is complete in Solidworks. Now let us create the fillets in CATIA. We'll take fillet, that is the edge fillet, and we'll apply a radius of 5 mm. Simply select the edges. We'll select this edge and this edge. Now click on OK. Here we are not able to see the edges. If you want to see the edges, then we have some rendering options or visual styles. We will see that. But before that, let us complete the fillet making process. We'll apply fillet here of 5 mm. Click on OK. You can see. In every software there will be a visual style tool. If you click here, you can see these are the various visual styles. Now you can see the edges. The first one is something like this. Second is with edges. If you just hover over it, it will show you what actually it does. Shading with edges without smooth edges. You can see. This is with hidden lines and so on. You can experiment on this and learn. Even in Solidworks we have the visual styles. Here if you see, the edges have gone. This is with edges. This is just the wireframe. This is with hidden edges. You can see. So these are the various types of rendering styles or the visual styles. With this, we have completed our example 26 model. In the next lecture, we are going to learn how to create cylindrical objects. In this lecture, we are going to create cylindrical objects. Cylindrical objects like shaft, gears, and any rotating part can be created by using the tool called revolve. So we have to find the revolve tool, and then we are going to practice simple examples using revolve tool. This you are going to do in every software whichever you encounter. I am going to do it in CATIA and Solidworks and show you how you are going to experiment. Let us see. In CATIA, I will take this sketch and I'll select this plane. And let me create a rectangle something like this. Now let us exit and we will find the revolve tool. In different softwares, the revolve tool is called with different names. You have to find out which is the revolve tool. Mostly the revolve tool will be there with the pad or the extrude tool. Let us see. We'll go to insert, sketch based features, and here there is pad. You should be able to identify the tool by using the icon, but I'll just show you and you can understand what is this revolve. Here in CATIA it is called shaft. Click on shaft and we have to select the sketch. Now you have to select the axis of rotation. I'll select this vertical axis and you can see something is happening. When I click on preview, you can see this rectangle has rotated about this axis that we have selected, which is this vertical axis, and during its rotation it has created a solid. You can also control the angle here. Go for preview. When you click on OK, this is the revolved body. So if your sketch is something like this, I'll delete this and create another sketch. Now exit. You can see in an instance such a beautiful object has been formed. So this is revolve. Now let me show you some different example. Now let us delete this object and I will create another rectangle here. We'll take the same plane and create another axis. Now I'll take this shaft and we'll select this sketch about this axis. You can see how the revolve actually works. If I show you preview, this rectangle has rotated about this inclined line, and during doing so, it has created a solid. When I click on OK, you can see. Just double click on this object and here we can go for 360 degrees so that it will form a complete ring. Click on OK. You can see here. Now let us go to Solidworks and apply this same technique. We'll take sketch here. Here we'll select sketch and we will take this plane. Let us take line and we will create a profile something like this. You can see. Now let us exit the sketch and let us take a sketch again and create another sketch. In this front plane, I'll create another sketch. Maybe I'll create a straight line, something like this. Press on the escape key. Now exit sketch. And we will go for features. We'll click on revolved boss. Select this sketch and this axis of revolution, we will select this axis. You can see. When you click on OK, for editing, I can go to this navigation tree and click on revolve. Here I can edit the feature. We can change the angle like we did in CATIA. You can see here, we can change the angle. Click on OK. Now, this is for forming solid. If you want to remove solid while rotating, then there is a other feature which is called here revolved cut. These tools are for removing solids. Revolved cut. Let us go for sketch. I'll take sketch on this plane and let me make a sketch something like this. It's a simple rectangle. You can see. Now, we will go for features, revolved cut. I'll select this sketch and this axis I'll select as the same axis that we have selected for the earlier sketch. You can see. When I click on OK, the rectangle has revolved about this axis and it has cut the body. So this is revolved cut. In CATIA also we have the same function. Let us check it out. I'll double click on the sketch and I'll make it straight. Now let me take any plane, maybe this plane, and create a sketch. The simple rectangle, something like this. Now exit workbench, and what I'll do is, we will go for the other tool. Here in sketch based features, we have this shaft and then we have this groove. You can see. We'll click on groove, select this sketch, and axis, I'll select this as the center axis. Click on OK. You can see the groove. So the rectangle, when it rotates about the axis, it has created a groove. So this is how we can create cylindrical objects. In the next lecture, we are going to practice example set 6. In this lecture, we are going to see the application of revolve tool by using example 30. Here you can see this is the drawing that we are going to convert into 3D model. We are going to approach this drawing for creating 3D model something like this. Here you can see this is the isometric view of the model. We are going to create this center object and then we are going to create this horizontal object. Let us do it and see. First, we are going to create this outer cylinder. We are going to do this example by using revolve tool completely. Of course, you can use the pad tool, but for practicing, we will use the revolve tool. In any software, whenever you practice this model, you should use only the revolve tool so that your doubts will be cleared regarding the revolve tool, and also you will learn the application of the revolve tool in the new software. Let us see. First, I'll take this plane and let us create a rectangle first. I'll create rectangle something like this. Now we will just take this edge and this axis and coincide. Now let us check the dimensions. Here this complete height is 50 and from center it is 25. Let us give the dimension. Double click on dimensioning. From here to here, this is 25 and this total is 50. Now this diameter is 50, so this radius will be 25. Now exit this sketch. You can see we have made a rectangle. We will select the shaft tool, select this sketch, and the axis will select as this axis. Rotation will be 360 degrees. Click on OK. You can see. Now we will take this same plane and we will create another sketch. The other sketch will be something like this. We'll take this origin. We'll make a horizontal line a vertical line, another horizontal line, a vertical line. Let us see the drawing. You can see here there are 2 steps. So I'll just make another step, something like this. No need for joining. We'll go for escape key. Now let us constrain this. Double click on dimensioning. Now let us study the drawing. Here this diameter is 25. So this is 25 divided by 2. You can see. Now from here to here, let us find out what is the diameter given. This is 32. So double click here, 32 divided by 2. 16. Now let us find the length. Here from center, this length is given as 50 and this edge length is given as 80. So from this face, or so to say that line, to the center, the dimension is 80, and again from the center axis to this line, the dimension is 50. You can see here 50 and 80. The same thing is there on the other side. Now we'll take these 4 lines, 5 lines, and we'll go for mirror about this vertical axis. You can see the figure is completely constrained. Let us exit the workbench. And now we will go for shaft. Select this sketch and we'll go for axis as this. It will be 360 degrees complete rotation. Click on OK. You can see. Now the same thing we will make it in Solidworks. Let us go for sketch. We'll select sketch and we'll select this front plane. Now let us take this corner rectangle and create a rectangle something like this. We'll take this edge and we'll take this point, which is the origin point. We'll coincide it. Now let us give the dimensions. We'll take the smart dimensioning. Now this total dimension is given as 50, and from this top to the origin, that is to the center line, it is given as 25. We are left out with this radius, which is given as 25, diameter 50. Now we'll just exit sketch and we'll go for features, revolved boss. You can see revolved boss. Select this and click on OK. You can see very easily a cylinder we have found. Now we will take the same plane on which we have created this rectangle and we will create our stepped portion like we did in CATIA. We'll take the front plane. You can see this is the front plane. Here we'll go for normal view and we'll take this line. From this origin we'll start and we'll create a stepped portion. You can see. And we'll stop somewhere here. Press on the escape key. We'll take this point and both we can make it vertical. This type of constraint may be there in some softwares like Solidworks. So you can just try it out. Otherwise, you can take a construction line and on that you can coincide. Or you can also choose the datum planes, that is the front plane, top plane or right plane. It's your wish. There are many ways to make the geometry. Now let us give the dimensions. I'll use smart dimension and we have seen the dimensions. This is 25 divided by 2 and from here to here this dimension we had given in CATIA as 32 divided by 2 and the length from this point to this edge, the length is 50 and again from this end line to this origin point, this is 80 mm. You can see the sketch is completely constrained. Now we can take mirror entities and we can choose this line, this line, this line, this and this line. These are the 5 lines that I want to mirror about this center axis. I'm not able to select the center axis, so we can take a plane. You can see we can take this right plane and we can go for OK. You can see. Now we'll just exit the sketch. You can see we'll take features and we will take revolved boss. Select this sketch about this axis. The revolve will take place. Now just go for OK. And we have the same solid that we have created in CATIA. Now let us make the center hole. For creating that we will use revolve cut so that we can practice it. We'll take sketch and we will take this front plane in which we have created the other sketch. Here we will take this normal view and we will create a step portion, something like this. A vertical line, a horizontal line, and you can see something like this. Press on the escape key to exit from the command. Now we'll take this line, press on the control button on the keyboard and select this origin. Both of them we will coincide. Now we'll select this edge and this line. Collinear. Again we'll select this edge and this line. Collinear. We'll just move this down. You can see. So what we are doing, we are actually creating this profile and we will revolve cut this to remove the material. This internal diameter is 32. Let us give it. We'll use smart dimension from here to this point. This is the radius, so 32 divided by 2. And if you move over here, this diameter is 40. So this is the step diameter. From here to this origin point, this is 40 divided by 2, 20. Now we are left out with only one dimension, which is this. This dimension has been given as 10 mm. Here, let us take 10 mm. And you can see, we have developed a completely constrained geometry. Now exit the sketch. We will take features and select revolved cut. Select this object, or so to say the sketch, and we will select the axis of rotation as this axis. Just click on OK. Before that, you check this is 360 degrees or not, because we have to remove the material all around. Click on OK and you can see we have completed our model in Solidworks. Now the same thing we will do in CATIA. We will take this plane. Just see the similarities between the two softwares. The technique is same. Even the tools are also doing the same work, but only the name of the tool is different and the way the tool is used is different. Now we can take profile here and create a sketch, something like this. You can see. Now we'll take this line and this vertical axis. We will coincide. We'll take this edge and this edge. Use the control for multiple selection. We can coincide. Similarly, we can take this edge and we can go for coincidence. Now we'll just move this Let us give the dimensions. This dimension is given as 10 mm and this radius is given as 32 diameter, so 32 divided by 2, and this dimension has been given as 40 divided by 2, that is 20 radius. The sketch is done. Now we will exit workbench and we will just use the groove tool. Select groove, select the sketch, and we have to select the axis. We can select the cylinder axis or we can also select the line of the sketch. Ensure that this is 360 degrees because we want to cut all around. Click on OK. And you can see we have successfully completed example 30. In the next lecture, we are going to see holes and threads on a solid body. In this lecture, we are going to create different type of holes and thread on a solid body. We are going to find the hole tool and practice, and also we are going to find the thread tool and practice on it. Here in CATIA you can see I have created a model. We have a simple block here and a cylinder which is on the top of the block. Even in Solidworks I have the same model. Let us create hole on this face. For creating hole, we have to find the hole tool. Let us go to this dress of features and we can find the hole tool. You can see there is thread here and we have the hole tool here in the sketch base feature somewhere here. Click on hole. You have to select the face on which you want to create the hole. Suppose I want to create the hole on this face. You can see there is a preview of the hole. Now this hole definition dialog box is very important. Here we can give the parameters of the hole. The hole has few very important parameters. First is the diameter of the hole. Next is the depth of the hole and the position of the hole. These three we have to give. Here we have this diameter and we have a depth. For positioning the hole, we can go to this positioning sketch. Click on positioning sketch and we can position the hole. You can give a dimension maybe from this edge to this hole center. We can give a value of maybe 30 and we can take dimension again from this edge to this hole. We can give a value maybe some 50. Now exit workbench and when you click on OK, a hole has been formed. You can see. Now the same hole we will create in Solidworks. Let us go to Solidworks and let us see where is the hole tool. You can see there is a hole wizard and we have an arrow here. When you click, there is a drop down menu which contains three types of tools. First is the hole wizard, advanced hole and thread. Let us go for hole wizard so that we can create a hole. Here you can see there are various types of holes. We want to create this straight hole. Now, I have told you there are three parameters that we have to feed. First is the diameter, second is the depth, and third is the position of the hole. So first let us see the diameter. Here you can see this is the size of the hole. So there are some standard size available, but if you want to take custom sizing, you can click here and we can give a value maybe some 12. Next, here this end condition is the height. Here it is through all. We can go for blind hole and blind hole will have a depth. Let us give some depth, maybe some 20 mm. Now let us take position here. You can see the position. Click on position. Where do you want to place the hole? I want to place the hole on this top face. Click and you can see. I'll position it somewhere here and if I take the normal view, You can see. We can use the sketch tools to position. Suppose I will take this smart dimension from this edge to this hole center, will give a value maybe some 25, and again from this center to this edge will give a dimension maybe some 55. Now we will close this dialog and you can see the hole. We can see the preview of the hole. Just click on OK. And the hole has been generated. This is a blind hole. There are various other types of holes that we can create. If you edit this, you can see these are the various types of holes. This is counter bore. Click on this and you can see a preview. This is the type of hole we can create. Here there are various standards. We can go for this ISO standard here, and here size we can take maybe some M12. You can see this is the standard size. Here there is a fit which is a predefined dimension, but we can go for custom sizing, and in custom sizing you can see this icon and understand what is the dimension. This is the smaller diameter. This is the bigger diameter. This is the depth of this bigger diameter, and this is the angle. This is the tip angle. You can give this parameter, and when you click on OK, you can see this is a counter bore. So similarly all the other holes we can create. Let us delete this hole. We'll just right click and delete. Now we will take hole again. We'll take this hole wizard and we'll go for this. We have another hole here, straight tap. You can directly create a hole with the thread. Here we can select the standard as ISO and we can take bottom tapped hole. You can try these options out. And here we will take a thread. Maybe we will create M14 thread. This is the depth of the hole. And this is up to what dimension you want the thread to be made. Here it is 34 dimension and up to 28 that the thread will be made. Now let's position the hole. We will go for positions. Click on this face. We will position it somewhere here and we will take normal view. Now we will go for smart dimensioning from this center point to this edge. We'll give a value maybe some 20. Again we'll take this point and this edge. We'll give a value some 55. Accept this and accept this. You can see. Let us go for the rendering. You can see the hole is formed here. Now this is a symbolic thread. We can go for the real thread. We will use Ctrl and Z key to undo. Now let us create a hole again. We will take hole wizard again and we'll select hole. Now we will go for this ISO hole. We can take drill size and here we can drill a dimension of. You can select here or you can also type. You can use custom sizing. We'll make a size of dia 12 hole. Here we can go for through all so that the hole will be made throughout the body of this block. Why I am making this dia 12 hole is we are going to create M14 into 2 mm thread. So for that dia 12 hole is required. We will take positions and I'll select this face and position may be here. You can give the dimensions. I have made the thread. You can see. We have created the hole. You can see here. Now to create thread, we can go for thread. Select this edge of the hole on which we want to create the thread, and we will select the dimension. We will go for metric tab, and the size is M14. You can see M14 thread. M14 into 2 mm. You can also select right hand or left hand thread. You can select multiple start, and so many things are there. You can explore yourself. But my job is to tell you the basic thing that you should learn when you are learning a new software. So just do not experiment on threads. We require only simple threads that we can apply onto our normal models. We don't need any advanced thread. We just need to select the standard thread and we need to apply. So just click on OK, and you can see the thread has formed. But here there is a problem. It is not cut. So we will find out a method how to cut it. We'll select here and we'll select on this edit feature so that we can edit that thread. And here in the starting we have a offset. Let's click and see what it does. You can see offset gives a starting distance to the thread. So here if I go for reversing this direction, you can see. So from 10 mm earlier to this phase it starts and it ends at a distance. So the depth from here to here is 30 and here to here is 10. The total is 40. When you click on OK, you can see this is what we wanted. So this is how you can create a thread in SolidWorks. Now this is internal thread. We can also create external thread. Click on thread. Thread location, we can select this edge and you can see the thread is getting formed. Here this end condition will go for up to selection. So up to this phase we will create thread, or you can also go for blind and give a dimension maybe some 20 so that it will form up to certain length. The dimension of this circle that I have used for this pad or extrude is 14 mm. So directly it is taking 14 into 2 mm. You can see. So here we can select 14 into 2 if it is not getting selected and just click on OK. Here it is showing an error, unable to cut thread on cylindrical face. Use extrude thread instead. So when you operate new softwares, you may encounter this kind of errors. So you have to solve this. Don't fear these errors. The errors will contain the tips that you should follow for making your feature. Now it is saying unable to cut thread on cylindrical surface. Use extrude thread instead. So let us find where is this extrude thread. You can see here in thread method, cut thread is there and extrude thread is there. Let us select extrude thread. The color of this thread has changed. When I click on this tick, we have formed this extrude thread. This diameter of this circle I have created as 12 mm. So when I have used 14 mm, it has created such a thread. Now such a thread has formed. We want to cut this shaft and we don't want to form a thread upon it. So let us click here, right click and edit feature. Now if we move down, we have to find out what is the problem. The size is okay, M14 into 2 mm, because our circle has a diameter of 14 mm, so we can easily form it But here in type you can see it is metric tap. Tap, as the name suggests, tapping is done for holes and not shaft. For shaft we can do a thread by using die. So we will use metric die. So like this you have to analyze and then you have to find out the right tool. If I click on this tick, so here we have used this extrude thread. Instead we can use cut thread. Click on OK again, and this is what we wanted. Can you see? This is a perfect thread. But still there is a little problem here. We can solve it by using the offset. We'll take edit feature and we'll click here offset. Reverse this, and here also we can take a value of some 30. You can see. Just click on OK. And now our thread is perfect. So this is what we wanted. So we have seen hole and thread on Solidworks. Let us go to CATIA and finish our hole making process. We'll create hole by using this icon. Click on hole, select the face. Here when you go to type, you can see there are various types of holes. Tapered hole, counter bore, countersunk. So the similar type of options are also present in CATIA. If you go for counter bore, it will have this step dimension. You can see this 15 mm is this step dimension, the diameter of this bigger hole, and depth is this height. So counter bore height and depth. You can also see it is given here. So you just have to explore the dialog box and you can understand. Now here this inside diameter is 10 mm and inside depth is 20. Let me give it as 30. When you click on OK, you can see this is a counter bore. Let us delete this hole and let us double click on this. We will take a diameter of 12 mm and a depth, maybe I'll take some 50 mm. Click on OK. You can see. Now we can take thread by using insert, sketch based features. We'll go to dresser features and use thread or tap. Now we will select the area where we want the thread. We'll select this. Now the limit face is this. You can see the thread is getting formed. This is the thread diameter, but we can take type as some thick pitch. It's a metric thread of thick pitch, and you can take the thread 14 into 2 mm. Now let us double click on this hole. We have this thread definition dialog box. We have this thread definition here. Just click on this threaded and we can create a threaded hole directly. We can go for thin pitch or thick pitch depending upon your pitch. We'll take 14 mm. Let the thread depth will be almost maybe 25 and the hole depth maybe some 40. You can select you want a right thread or left thread. Click on OK and OK again. You cannot see the thread in CATIA, but it will be there in the part navigator. You can see this hole. This hole is with a thread. You can see this icon. It is a thread. Now this similar type of thread you can make it on this extruded circle. Let us go to insert, dresser features. We have thread here. Just select this face on which you want to create the thread, and the limit face is from where you want to start the thread. I want to start the thread from this face. You can see the thread depth. We can give the thread diameter. Already the diameter has been made, so we can give the depth as some 20, and here in case of diameter we can take metric thick pitch, M14 into pitch is 2 mm. That's it. You can use right hand or left-handed thread. Click on OK. You won't be able to see the thread, but you can see the thread here. So this is how thread and holes are getting generated. You will be clear about this when we use this in an example in the further lectures. In the next lecture, we are going to discover plane creation tools.